Good evening. I figured I would quickly share some video processing of Mars that I took on November 6th. And so I took multiple clips, but I just hook up my astronomy video camera to my telescope, and this is a sample of what you get. And so that's a picture of Mars, and it flickers and dances because of the atmospheric conditions, and so it's very, very difficult to get an absolute clear image straight out of the camera. So the whole idea behind this is to take as many frames as you can, and every once in a while the video will capture a clear frame. So what we will attempt to do is we take all the frames contained in the video and process them in such a way that we throw out the bad ones, keep the good ones, and then stack those good ones together such that we have a final image that we can further clean up with just some normal photography editing software. So let's give it a go. Let you see what goes on behind the scenes, and here we go. So the software I use is Image Plus, but there are some free ones that are out there that can do a similar job. One of these is PIPP, which is Planet Imagery Photo Processing, I think. Registax is another free one. There is a WinJupos software out there, so when you're doing Jupiter, because it spins so fast, you can account for the spin of the planet, which is kind of fancy, but those are some of the free ones, and this is the software I use here. I'm not going to go into any great depth, but I'm just going to give you just a very brief idea of what it takes to make a picture from a video. So we're going to start here and do a video file display and processing. I'm going to select my video, and then I'm going to flip over here to the next tab. I'm going to keep the best frames only. I'm not sure what percentage that is, but if I wanted to, I could say just give me A and B, or just A, and I could edit the percentage that I want to keep. So there's different ways to set your quality level, is the whole point there. We're just going to run best only. It's a planetary type disk. These are combination settings, so it's going to take the average of all those that it keeps in terms of pixel values and use those as the brightness levels. Otherwise, you can exclude the minimum and maximum value. So if you have really bright pixels or really dim pixels, you'll throw those out. So that might be handy sometimes if you have an airplane fly through your shot, because it would get rid of those bright pixels. So these are just different methods. Otherwise, what we're going to do, we're going to ask it to grade all the frames, because we're using the grade option up above. Calibrate just sets the level or the tone from each picture to be equivalent from 0 to 100. These are all pretty good pictures because they're all taken at the same time. We won't use that. Once you grade them, align them, so it's going to find the planetary image and combine finally as the last step. So let's do this. So it knows that there were 4,299 images in that video, and it's rapidly running through all those frames and making quality decisions, and it'll build a log file of to keep track of all of this. But basically now we're just waiting for it to run through the number of frames. Now I did take other ones. Now there are ways. I did take a dark frame video, which is just a video with the lens cap on, so it's all black, and you can enhance your pictures even more by subtracting out the noise that's in your camera, and that's the purpose of a dark frame. So there's a way to do that. There's what's called a flat frame, and that's a frame that includes the light, but that captures the dust and other imperfections of your lens system, and that'll subtract those types of errors out of the picture too. So there, you can get it as wild as you want. You got to have a process to take the required images when you're out there shooting. And then just, take it step by step and go through the process. This is probably the longest step here for this particular video. I normally don't go at it this direct, with just bring in the video, grade it, stack it, and process it. Although you'll see that you can get fairly good results with this minimal approach. I sometimes, when I do the planets, I'll come in, I'll use the PIP software. I'll just start it here. So this one's a little bit different. You can add a source file. Same thing. I could grab that file. There it is. And I can walk my way through all the various tabs as far as setting more parameters. I think I probably need to pick down here planetary, and that'll help set some of the default settings. But you walk your way through. There's quality, right? And you can animation you don't need, output options, okay. You can choose your output file types. You can have another astronomy video format. You can have it output images. So there's a little more versatility in this approach depending upon what you need to do. And then finally you just say, hey, go do it, and it'll process. Now one thing that's good about this one is that you can have it crop and center the image. So if your planet is bouncing all the way around the frame like you saw, it can basically move the planet to the center of the image and crop it down so it's always in the same spot. That increases your processing speed if you have cropped files because they're smaller. So there are advantages to doing it this way. Okay, well, so it finished, and I'm going to display the combination. So you can tell that this was a little fuzzy. This is a little clearer. I'm not really sure if this is the number of frames it used, because I haven't ran this one very often, but this picture does look pretty good. So now you can start with the picture, and one of the first things you'd probably want to do is stretch it. And let me turn on the graph here. You can see that all the pixels are all scrunched up, and so when you apply a stretch, what you're actually doing is redistributing or making that histogram of light stretch across more of the spectrum. It's not changing the values so much, but it's giving you a little bit more control as to when you apply other effects. You've got more space to work in. So that was the white point, and we'll do the mid-tone point here. And see, it's getting a little brighter over here, so I'm gonna touch it down a little bit. And this is where it gets a little artistic. It's just what you think looks right to your eye. And overall, that might be a little dark. That looks pretty good, right? And it almost looks like I'm getting a little bit of white there as far as like a polar cap. So I think the picture will be fairly decent. That's probably one of the clearer images I've made, so I'm rather pleased. And so that was stretching. And then typically you can do like a smoothing operation. Let's do a multi-resolution. So this has to do with what they call wavelets, which I'm not really sure how they work, but you know, there's a more coarse setting, and you can push this until it kind of, you can see it'll go bad if you go too far, and you can see it, the edges here are really getting poor. But I'm going to bring that back. Okay, that's not too far out of line. But you can see that you're getting a little bit of detail out of this operation. See, if I go far again, it's too much. Maybe not enough. That might be too much. And it's looking okay. And we'll push that one a little bit and say done. Okay, and we can come back in with a simple smoothing. And probably not a whole lot more we want to do here, other than we could change the saturation, push that just a smidgen, and then give it a little bit more red is red, or for Mars. And it's not really changing the color, it's changing the saturation, making it richer. And you know, overall that's looking like a pretty good planet picture. Now, at any time in all of this, if I don't like it, this is just like a recorder. You know, it records all the steps that I've done, so I can delete or reorder steps. You know, so it's a little bit of a batch process, but it does have some flexibility in remembering what you did. So you're not really altering the original picture, you're just altering the image in memory. And so if we're happy with all of this, we can just close out and close that. That'll get rid of the video, and we'd say, hey, that's a great picture, ship it. So we can do a save a copy as, and we'll just say Mars, and that's a fit format. So that saves it with the most pixel depth. And we can do a save copy as, and we'll do a JPEG. Oops. JPEG only has 8-bit depth, so oops, there we go, and save. So get out of that, go back here. Here was the stacked version. We have the processed version, and then we have the JPEG version. So there it is. That's our finished product. So hopefully you found this interesting. Maybe I'll make another. Thank you.